epsilon-NFA or NFA with epsilon. An epsilon-NFA is an extension of NFA. And the transition function of epsilon-NFA is defined as from a state by taking an input symbol or by taking epsilon, you can reach to a number of states. And epsilon can be denoted with the help of this symbol or by lambda. And in NFA, from a state by taking an input symbol, you can reach to a number of states. But here you can take the epsilon as well. In diagrams, epsilon transitions are depicted by labeling the appropriate arcs with epsilon. But it doesn't mean that epsilon has become an input symbol. So in diagrams, from a state, by defining the transition of epsilon, you can reach to another state. But it is not our input symbol. Okay. The automata may be allowed to change its state without reading the input symbol, since epsilon simply is the empty string. So you are not reading any input, but still you can change your state, or you can reach to another state. And this empty string can be denoted with the help of this, where your initial state is your final state as well, or like this you can define the epsilon transition, or you can say epsilon empty string, epsilon or empty string. So this is also denoting the empty string. Next point is both NFAs and epsilon NFAs recognize exactly the same languages. In fact, DFA, NFA and epsilon NFA, they all recognize the same language, and there is a way of converting the epsilon NFA into NFA or into DFA. Our first question is, construct an epsilon NFA for the given language a power n such that n is even or divisible by 3. So in order to construct the epsilon NFA for this language, just divide it into two parts. In the first part, n is even, and in the second part, n is divisible by 3. So just construct the NFA for these two parts. So when n is even, my initial state will be my final state, and after taking a, we will reach to this state, and from here, when we will take another a, you should reach to the final state. So it means it is accepting epsilon as my initial state is my final state as well, and after that it is taking 2 a's, then it is accepting 4 a's, 6 a's, and so on. Now construct the NFA for a power n, where n is divisible by 3. So n is divisible by 3, it means initial state will be my final state, and after taking 3 a's, you will reach to the final state. So here it is accepting epsilon, a power 3, a power 6, 1, 2, 3, 4, 5 and 6, then a power 9 and so on. Now to combine these two NFAs and construct the epsilon NFA, we have to take one more state, and these two states can be connected to this state by using epsilon. Now this epsilon NFA can accept the language a power n, where n is even or divisible by 3. So this is how we can construct the epsilon NFA, or you can just simply construct the multiple NFAs and then combine these NFA with the help of the epsilon transition. Now you can try the construction of DFA for this given language, and then you will get to know that the construction of epsilon NFA is easier and less time consuming. Okay, so just try to construct the DFA for this language. Our next question is, construct an epsilon-NFA for the language which accepts the strings of any number of A followed by any number of B followed by any number of C. In the beginning, there can be any number of A followed by any number of B followed by any number of C. Since in the beginning we can have any number of A's, so this will be my initial state, and at the end we can have any number of C's, so this will be my final state. And to connect all these states we can use epsilon, since we are designing the epsilon-NFA. So this will be my final epsilon-NFA for the given language. Now here you can check, it can accept A, epsilon, epsilon, and this is your final state. It means it can accept any number of A's, and after that epsilon, B, epsilon, final state, so it can accept B, double B, triple B. Similarly, it can accept any number of C's. Apart from these strings, it can accept A, B, B, or A, B, C, double A, double C, etc. Since it is given in the question that any number of B's, it means B can be 0 times as well, right? So this is our final epsilon-NFA. Now let's suppose if I have to construct the NFA for the same language, then just remove all the epsilon. Now after A you can read A or B and you will reach to this state, and then either you can take B or C. After B you can again take B and then C only, so you will reach to the final state. Now it can, since it can accept the single A as well, so this will be my final state, or it can accept double B or single B, so this should also be my final state, right? Now it can accept A, double A, or triple A, B, single B, and you are here, double B, 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 triple B, 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 and B. Similarly, it can accept C, but here it is not accepting C, so we have to define this transition. So C, then 2 times C, 1, 2, 3, or it can accept A, B, B, or A, B, and then C, etc. Now just remember this thing, we have defined 2 different transitions from the same state for input A, because this is an NFA, and in NFA we can define the multiple transitions for the same input from the same state. Okay, so this is our final NFA. Now let's suppose I have to construct the DFA for the same language. Then how we will define it? Any number of A followed by any number of B followed by any number of C. Okay. Now, since this is a DFA, so we have to define the transition of each input from every state. And here we have 3 input alphabets A, B, and C. Now tell me, can I define the transition of C here? No. Why? Because in that case it can accept CA, but A should be followed by C. So this will be a wrong transition. Now tell me, can I define the transition of C here? Again, in that case it can accept what? It can accept CB, but B should be followed by C, right? So this can't be the transition. Now check, can I define the transition of C here? Yes, because in that case it can accept AA CC, which is a correct string belonging to this language. So this will be my transition. So from this state we have defined the transition of A, B and C. Next I have to define the transition of A from this state. As it is given in the question that B is followed by C, B can't be followed by A. So the transition of A will be defined on trap state, because we can't read A after reading B, and the transition of trap states will be on self loop. Now from this state also we have defined the transition of A, B and C. Now we have to define the transition of A and B from this state. Again, after reading C, you can't read A or B. So the transition of A or B will be defined here. So this is our final DFA corresponding to the given language. So as you can see that the construction of DFA is more time consuming than NFA or epsilon-NFA. That's why we prefer to construct the epsilon-NFA or NFA, then we convert the NFA and epsilon-NFA to the DFA. Our next question is, construct an epsilon-NFA for the given language, which is W, belongs to ABC star. It means you can take any number of times A, B and C, such that W contains at least one string that consists of 3 identical symbols in a row. It means it should accept at least AAA or BB or CCC, and here you can take any number of times A, B or C. Here also you can take any number of times A, B or C, right? So similar to the first question, we will divide this question into 3 parts. In the first part, it can accept 3 A's, and in the state you can define the self loop of A, B and C. Similarly, it can take 3 B's, and after that it can take any number of times A, B or C, or it can take 3 times C, and then it can take any number of times A, B or C. Now these 3 are separate NFAs. This will be your initial state, है ना? So here you have 3 separate NFAs, and in order to combine these you can take the help of epsilon. Now since in the beginning you can take the any number of A, B and C, so here also you can apply the self loop of A, B and C. So this is the final epsilon-NFA for the given language.